I have already explained you it is better to work in digital domain as compared to the analog domain, especially if I talk about transmission and storage, because efficiency and cost is reduced in case of digital. So what we want to push most part of our analysis towards the digital side, but you already know all the real life signals are analog in nature. So how we can process it by using the digital system? That's why I'm going to explain you the whole arrangement, how it actually works, and we will also try to find out the part of this arrangement that we have to study in this course, in this digital electronics course. So at the input we have the analog interface, and also at the output we have analog interface. I will call this one analog in, and this one analog out, and I'm considering every action in this part from starting. The start is the measuring of signal, and then we convert it to the electrical signal. For example, if you are measuring temperature of one furnace in the steel plant, then definitely you have to introduce the thermocouple in the furnace, and you will convert the heat energy, or you can say the difference in the temperature, to the electrical signal that we call as the transducer. In the same way, if you are measuring the sound, then definitely you have to convert it to the electrical by using the transducer. I'm considering that in this, and also I'm considering all the manipulations like increasing the amplitude, etc. and etc. in this. Similarly, I'm also considering all the processes that you have to do for making the analog input available to outside world in this. Now we will especially focus on how to convert this analog signal to digital, and then again the digital signal back to analog. So let's see what we can do. We use analog to digital converters, and I will call it ADC, where A stands for analog, D for digital, C for converter, and I will use a single arrow because we are having the analog as input. Now this ADC will provide the digital signals that will go to the digital system for processing, and I have shown it by the thick arrow or multiple arrows because this one is multi-bit. I will explain you what is bit. It is similar to digit in decimal system, and we call it bit because we are working in the binary system, and this one shows that there are more than one bit. That's why I have used thick arrow to represent it. Now this digital system comes into action. What is this digital system? You are having one in front of you, the computer. The computer is the digital system. The calculator is the digital system, or you can say the watch. Your watch is also digital system, and the measuring instruments are also the digital system, etc. and etc. So this digital system's task is to manipulate the data and process it according to your need, and once it is processed, it again has to give it back to the real world, and then the output is the multibit. It is then given to the another block that we call as DAC. D stands for digital, A stands for analog, and C stands for converter. So this one is the digital to analog converter because the output of this digital system is digital, and we cannot give this digital system to the outside world. For example, if you are walking on a railway platform and you see the time and it shows 1000, 1000. So what will you understand? What is the time? 1000 by 1000. What kind of time is this? 1000 minutes and 1000 hours? No, this is in binary. It is actually 8. This represents 8 in decimal, and this one is also 8. So it is 808, and if I represent it in binary, it will look something like this. So it is definitely very tough to interpret. So we need to convert it in the form that can be understood by everyone. So we need DAC, digital to analog converter, and again it is given back to the analog output. So this is how the digital system works, and we have to study this part, not completely this part. We are not going to study computers in this course, but this digital system is made of the subsystems. So let me write this thing down. The digital system is made of the subsystems, subsystems, and these subsystems are made of modules. I'm actually making the hierarchy of the digital system, and after modules we have basic units. I'm not going much into the basic unit because we don't have the background knowledge to understand this, but you can consider the logic gates. And what is logic gate? It is nothing but a concept. If I say AND gate is there, then there are some inputs and the output is depending upon the logic that we are using, and we are using AND as the logic. But what actually goes inside the AND gate is the circuit. We have the circuits, and this circuit is made of the transistors, resistors, capacitors, etc. This transistor, resistor and capacitor makes the logic gate, and depending upon their arrangement a particular logic is set and the input is given and then the output is generated. So we have to study this part in the coming lectures. We will see how the logic gate works and what are the different logic gates available to us. We will also see Boolean algebra, and there are so many things depending upon this logic gates or the basic units. And when we move forward in this course, we will study some modules also, but we will not study the digital system like computer, calculator, watch, but we will study some modules definitely. So this is the outline of the course that you have to study in the coming presentations. So I think this is all for this presentation. See you in the next one.